Homework packet 2A, lesson 204. For exercise 8 to 12, do each of the following. A. Tell whether the given information is enough to show that the triangles are congruent. The triangles are not necessarily drawn to scale. B. If the given information is enough, list a pair of corresponding vertices of the two triangles. Then state which triangle congruence postulate guarantees that the triangles are congruent. So let's look at part A. Problem 8. We have A, B, C. 1 tick mark, 2 tick marks. We get D, E, F. 1 tick marks and 2 tick marks. So we can say segment AC is congruent to segment DF, and segment AB is congruent to DE. So what we have to do is this congruent? Is this information enough to say this is congruent or guarantees that are congruent? In order to say congruent, we have to say angle, side, angle, side, or side, side. If we have to be able to say these things, right? So now the question is, if you're looking at this one, do they have enough information to satisfy one of these conditions? The answer is no, because we only know that segment AC is congruent to DF and segment AB is congruent to segment D, and this is not really, that's SS, side. However, we don't know that we don't know whether segment BC is congruent to segment DEF. If so, we can use SSS. We can say these two are congruent by SSS, or if we know that the angle A is congruent to angle D, then we can say this is congruent because of SAS. But we don't have those information, so we cannot say this is congruent. So use that idea to the rest of the problem. Problem 13. In triangle ABC, ABC. I always draw that looks like equilateral triangle, so let me just do it differently. ABC, CD is a bisector of ACB. So I'm going to draw that. That's a bisector. So those two are exactly the same. Which of the following conjecture is true? I'm just going to go through A. It says there is not sufficient evidence to prove that angle ACD is congruent to CDF. This doesn't look like exactly the congruent, but you can rely on your eyes. You gotta come up with the evidence to fulfill the conditions, either ASA, SAS, or SSS. So can we tell these are, well, we can definitely say these two angles are exactly the same because you're bisecting those two angles, but can we say, so we can we have a possibility of being able to use SAS or ASA, but can we get other information from here? If not, A is not. Obviously we can't, so these two are not congruent. So do B, it says B says triangle ACD is congruent to BCD, is true by the ASS postulate. In each triangle, the side between the two angles is CD. Okay, definitely we can have this, we can say this one is the same. So if you separate that, you'll have ACD and CDB, and definitely the length from here to here is exactly the same. So and the angle here and here is the same. So that's B. This is multiple choice, so there's only one answer out of 4 choices. Problem 14, in the figure at the right, which is something like this, A, B, C, D. Segment BD is the perpendicular bisector, therefore this is 90 degrees. So if we separate these two, we'll get these two triangles, which is B, D, A and C. Definitely these two are exactly the same because it's attached and there is no overlap. And it says perpendicular, therefore this is exactly the same. And the question is, are these two congruent? And why? If so, why? Can we say ASA, SAS, and SSS? Let me give you a hint. Perpendicular bisector, actually this one actually bisects this segment AC, therefore the distance from the length DC is equal to length AD. So does that help? Problem 15 is take it farther problem. That's optional problem. If you want to prove yourself to me, please do it, but I'm not going to give you any hint. Problem 16, that's actually extra bonus problem, so if you need to boost up your grip, do it. Problem 16, it says, assume you know that the sum of the measure of the angles in a triangle is 180 degrees. In triangle ABC is congruent to DEF, and the measurement A, right there, and the measurement D is 72 degrees. Measurement B, measurement angle E is 47 degrees, and AC, so those are the corresponding parts that are congruent. AC equals DF, which is 10 inches. Are these two triangles congruent? In other words, if you have that information, well, yeah, are these congruent? And why? It's AAS actually, right? Angle, angle, side. That doesn't fit those three things, ASA and SAS and SSS. However, as part B says, actually this guarantees the triangle congruence. So that's actually the answer for A. Thank you for watching. I'm giving out the answers right now. Why this actually AAS guarantees the triangle congruence, even though it's not one of the three triangle postulates? So I want you to think about that.